Orders are vanishing, dashboard count just dropped 20%. A unique index on the hybrid table was silently swallowing duplicates. Let's explore. You'll learn how Snowflake's hybrid tables and Unistore architecture enable low-latency transactional workloads alongside analytics, and how to avoid common pitfalls. Hybrid tables combine row-oriented storage for fast point lookups and small transactions with a dedicated column store for analytics. They support ACID transactions, indexes, and foreign keys, letting you unify OLTP and OLAP workloads in one system. It starts with a DDL statement. Creating a hybrid table is similar to a standard table, but with the hybrid keyword. You define a primary key and optional secondary indexes. Snowflake automatically manages data placement between row and column stores. We create a hybrid table for orders with a primary key and an index on customer-id. We insert sample data, then run a point lookup and an analytical query. Using alter table, you can add or drop indexes, add foreign keys, use merge for upsert, and monitor their usage with show indexes. Indexes are crucial for performance, but over-indexing can slow writes. This code adds a secondary index on status, drops the customer index, adds a foreign key, and uses merge with a using clause to perform an upsert. Finally, we list indexes. Hybrid tables support ACID transactions with snapshot isolation, using optimistic concurrency control. You begin a transaction, perform your updates and inserts, then commit. If two transactions update the same row, a write conflict causes an error, one succeeds, the other fails. Your application should catch that error and retry. We start a transaction, update inventory, insert an order, and commit. If a conflict occurs, we roll back and retry. When you submit a query, for point lookups always filter on indexed columns. Use explain to verify index usage. For range queries, create secondary indexes. Large aggregations fall back to the columnar store to produce the final result. We use explain to check for index scan, create a secondary index on order date, run a range query, and then an aggregation that uses the column store. Unistore is the foundation. Data is first ingested, then stored in a row store for recent data and fast operations, while a column store handles historical data for analytics. Snowflake automatically moves data between these tiers based on age and access patterns, and the unified query engine lets you query across both seamlessly. You can check and set the row store retention time. Use show parameters to see the current setting, then alter table to change it. Use information schema to monitor storage usage. With hybrid tables, the row store handles atomic inserts and updates, and the column store runs analytics directly on that same table, eliminating the separate OLTP DB and powering a live dashboard. We create an inventory table, then in a transaction we deduct inventory and insert an order only if stock is sufficient. Finally, we run a real-time dashboard query. Hybrid tables have a 10 GB row store limit and a maximum of 10 indexes. They don't support search optimization or materialized views. Monitor usage and drop unused indexes. Use information schema to monitor row store size and index count. Drop any unused indexes to avoid write overhead. The root cause: the hybrid table had a unique index on order-id. Due to a race condition, the app generated duplicate IDs. The index rejected the second insert without raising an error because error handling was misconfigured, causing orders to disappear. The fix was to use a sequence for generating unique order IDs, remove the unique index, switch to a hybrid table, add explicit error checking on every DML operation, and then test concurrent inserts to confirm the solution prevents silent failures and ensures data integrity. If you've a unique index and insert a duplicate, the insert fails silently unless you catch the error. The fix wraps the insert in a begin exception block that catches unique constraint violation, so you can handle it explicitly instead of letting it fail silently. Always check for errors after DML operations. Each index adds overhead on writes. Excessive secondary indexes multiply that overhead for every insert and update. Dropping down to a single essential index, as shown in the fix, eliminates that redundant write work. If two transactions update the same row, one will fail. Without retry logic, your application may lose updates or crash. A retry loop catches the conflict, rolls back, and retries up to 5 times. To diagnose issues, use explain to verify index usage, check for duplicate keys, and monitor transaction history. Always test concurrent inserts under load. Let's review interview questions about hybrid tables and their concise answers. Frequently asked questions about hybrid tables. To recap, hybrid tables combine row and column storage for both transactional and analytical workloads. Use primary keys for fast lookups, handle conflicts with retry logic, and monitor storage limits. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.